Good morning, students. In this chapter, till we learn about the pressure, its dimension, its formula, absolute pressure, what is gauge pressure, what is the atmospheric pressure. Now, we are going to learn how to measure pressure by using instruments. In our syllabus, there are two instruments given. One is barometer and the second is open tube manometer. Now, what is barometer? Barometer is a device which is used to measure the atmospheric pressure. The Italian scientist Torricelli invented this barometer. What barometer consists of? Barometer consists of a glass tube filled with the mercury and a dish containing mercury. The diagram of this barometer, simple barometer, is shown in the figure. Now, what is the diameter of this glass tube? This glass tube is about 1 meter in height and its diameter is equal to 1 centimeter. Now, how this barometer can be prepared? This barometer can be prepared such that a glass tube is filled with the mercury up to its brim and it is then quickly inverted into the dish containing mercury. Some of the mercury spill out of this glass tube and the level in the dish, the mercury increases in the dish. So a region is created here. This region is called as a Torricelli vacuum. Why vacuum? Because there is no atmosphere, there is no air. Some vapors, mercury vapors can be present there. This region here is called as a Torricelli's vacuum. And if there is no atmosphere, so the pressure at point A, we can say that it is equal to 0. So we can write here the pressure at point A is equal to 0 because there is no atmosphere. Now consider a point B which is placed just below the point A and the height of this liquid is equal to h. Now we also consider a point C which is on the free surface of the mercury inside the dish. As this point C and point B, they are in the same horizontal level, the pressure at B and C will be equal. So we can write here this PB is equal to PC. Now, how we can calculate the pressure at point B? Easy. The pressure at point B calculated such that this PB is equal to PA plus H rho G. We derived this relation in the last lecture. So, what is PB is equal to? This PB is equal to PC, and what is PA is equal to? It is equal to 0 plus H rho into G. Now, what is the pressure at point C? This point C is open to the atmosphere, so the pressure at point C will be equal to atmospheric pressure. So we can write here as this atmospheric pressure PO is equal to H rho G. So by using this barometer invented by Torricelli, we can determine the atmospheric pressure. So here what is the H? H is the height of the mercury in the liquid column. As this height increases, the atmospheric pressure also increases, or if the atmospheric pressure increases, this H, the height of the liquid in the glass tube also increases. What is rho? Rho is the density of the mercury, which is equal to 13,600 kg per meter cube. And what is the gravity? This gravity is nothing but 9.8 meter per second square. So by using this barometer made by Torricelli, we can easily easily calculate the atmospheric pressure. The atmospheric pressure is measured in the unit which is called as a torr, or which is also measured in the height. What height? It is the height of mercury. Now the standard atmospheric pressure contain 76 centimeter of mercury. What does it mean? It means that at a standard pressure, this mercury level is equal to, this height is equal to 76 centimeter of Hg, which is also equal to 760 millimeter of Hg. Or this pressure also measured in another unit, it is called as a torr. What is torr? 1 torr is equal to 1 millimeter of Hg. It means if the height of the mercury in this glass tube is equal to 1 millimeter, then we can say that the pressure is equal to 1 torr. So we can derive the relation between the atmospheric pressure, we can denote it in the torr. So what is the atmospheric pressure? Atmospheric pressure is equal to 76 centimeter of Hg, which is equal to 760 millimeter of Hg. But we know that 1 millimeter of Hg is equal to 1 torr. Therefore, we can write the atmospheric pressure P0 is equal to 760 torr. So this is the simple relation. This is the atmospheric pressure in the terms of unit torr, and this is the pressure in the term of height, that is 76 centimeter of Hg. Now, this is a barometer which is used to measure the atmospheric pressure. Now, if we have to measure the pressure difference between the 2 points, we use another instrument which is called as the open tube manometer. This open tube manometer consists of a U-tube, in which a liquid of low density is filled up. For example, water, kerosene, they are the low density liquids, they are filled inside this U-tube. One arm of this U-tube is open to the atmosphere. So we can say that the point A is open to atmosphere, therefore the pressure at point A is nothing but the atmospheric pressure PO. Now, the another end of this manometer, the other arm of this manometer is connected to a container denoted by this letter D. Now, consider a point C which is placed on the free surface of the other arm of this manometer. So, if we have to calculate the pressure at point D, we have to first calculate the pressure at point C. And how we can determine the pressure at point C? This pressure at point C can be determined by using a simple formula. What is the formula? Let's see. We know that this point A, it is open to the atmosphere, so we can write the pressure at point A, PA is equal to P0. Now, for determining the pressure at point C, we consider a point B in the same horizontal level in this arm, which is just below, about a height h below the point B. So, what is the difference between these 2 points? These 2 points is equal to h. Now, by using simple relation, what is the pressure at point B? The pressure at point B is equal to PA plus H rho G. Now, what is PA? PA is nothing but the atmospheric pressure. So, we can write here, it is the atmospheric pressure PO plus H rho G. This is the pressure at point B. Now, as we stated earlier, this point B and point C, they are in the same horizontal level. So, the pressure at point B must be equal to the pressure at point C. So, we can write here as PC, pressure at point C, is equal to PO plus H rho G. Now, if we have to determine the pressure of the container, so according to Pascal law, what is the Pascal law? Pascal law states that when a pressure is applied at a point of a fluid enclosed in a tube at rest, is distributed uniformly. So the pressure at point C is equal to the pressure at point D according to the Pascal law. So we can write here the pressure, if we denote the pressure at point D is equal to P. So what is P is equal to? It is equal to P0 plus H rho G. So by using this formula, we can determine the pressure difference between two points. Now, this container measure the gauge pressure, so we can write this equation also as P minus P0 is equal to H rho G. So, this is nothing but the gauge pressure, the difference between the pressures at point, what is P? P is the pressure at point D, and what is P0? It is the atmospheric pressure. So, in this lecture, we learn about the instrument which are used for the measurement of pressure. The first one is barometer. This barometer is used to measure the atmospheric pressure. How we can measure the atmospheric pressure like that. Now the second one is the open tube manometer, which is nothing but open U tube containing one arm is open to the atmosphere and second is connected to the container. If you have to calculate, determine the pressure at point D, then by using such process we can determine the pressure difference or the pressure at point D. So in the next lecture we are going to discuss the another property of the fluid, which is nothing but the surface tension. In the surface tension there are intermolecular forces, cohesive force, adhesive force, range and the sphere of influence. Such terms we are going to learn in the next lecture. Here we are going to stop now. Have a good day. Bye.